And audio sounds okay. Is everybody seeing the screen okay?
Yeah. Yeah. Yes.
Good.
So what did you think of that site, Ernie? Did
Uh,
you take a little bit more of a look at like what kind of stuff he has?
yeah. I'm not sure if I should thank you for that or how to approach it because I'm going to be kind of busy playing around with that for a while.
Well, but also I'm scared of it.
Yeah, and I'll touch a little bit on that here. So I'm not sure if we got. There may be a few more that kind of hop on here as it progresses. So I might as well kick it off, and I'll give my thanks to you right now, Kat, for pointing that out. And I'm not sure how I kind of got talked into doing this, but here we are. um, so the other day, Kat kind of presented a website to me and expressed some concerns about the safety of Wireshark captures, and I guess in one of the lectures it talks about we're safe to look at Wireshark captures, but I think on the flip side there was a component, and correct me if I'm wrong, Kat, that said that it's not necessarily safe to do. Is that?
Yeah, it's like day one, I think, of this week, and it says it's good to analyze these PPACs, and but then in the next sentence it says, but it's also not safe, basically. And so I almost posted that site for the entire group in our cafe, but then I took it down and I thought, oh my gosh, like I'm not comfortable doing it myself, and I don't know if my network is isolated. So then I approached Ernie and thought, I need somebody who knows what they're doing before I go and give this to people, and somebody, accidentally does something. I don't want to be responsible, because on one side we get to see what it looks like, but on the other side I'm not there yet to go and know if it's safe and if it's going to ruin my host machine.
For sure.
So no, so thank you for doing this.
Yeah, no problem. And full disclaimer, I'm no expert. I'm learning a lot of this stuff, or at least some of it's coming back from old school days. So um, don't think I'm an expert. I'm not trying to take away from any mentors or instructors or anything like that. But I'll show you what Kat and I were talking about, and dive into some Wireshark stuff. So that way, if anybody's struggling with Wireshark and trying to figure out indicators of compromise or just even starting points in all that data that we get with Wireshark, this will be a good example for some of that. If you're already an expert in Wireshark, certainly appreciate any interjections and different ways of doing it, because I'm certainly no expert here. Same with the forensic stuff. As we get into that, and if anybody has questions, I can answer them. But my way of doing things might be different than your way or all kinds of other ways. It's all about putting together sort of a jigsaw puzzle. I might start at the edges, or I might be able to identify pieces of images that are familiar, and I would start there, whereas somebody else might look at it totally different. It's like everybody on the call here, if we had the exact same jigsaw puzzle, we're not always going to start on that same corner piece, for example. We might have a different way of approaching it. So when we're doing all this forensics, whether it's through Wireshark or anything else, that's how to assemble it. Go with what you know and start piecing things together, filling in the blanks. So that being said, what Kat and I were talking about the other day is this site here, malwaretrafficanalysis.net. I'll just jump back here. So the main page is pretty simple. This guy's got an about page and some traffic analysis exercises, some tutorials and workshops. I haven't been in here yet, but he alludes at least in the one project that we're going to look at, to some interesting ways of setting up Wireshark for getting information out of it. So I definitely want to dive into there and start diving into a lot of his other stuff here. Some of his current stuff that he's got listed, and the one that we're going to look at today is called WarmCookie, and it's a traffic analysis exercise. He just posted it the other day, so it's fairly current. And we should be able to get some interesting results out of it anyway. Jumping on here, this is the detail page for it. I've already played around with this, so full disclosure, I've already gone through and answered all the questions, solved all the problems here to it. I wanted to do this in an isolated environment because I have no idea what's going on here. So I did this in a completely isolated environment and brought it through into my main machine here on our trusty Windows virtual machine. He password protects files just to make it a little bit more difficult for people to get into and not mess anything up. You got to take a few extra steps to cause havoc on your machines. Background of this particular exercise: Windows host was infected, seems to be from WarmCookie malware. How that was determined, I don't know, but we'll just go with that. We're already given lots of good information here. The LAN segment range that it's on, so 10.8.15. Assume everybody can see the screen good. If anybody needs it zoomed in, let me know. We've got a domain, we've got an Active Directory domain controller, and the host name for that. We've got our Active Directory environment name, Fontaine Blue. LAN segment gateway 10.8.15.1 and broadcast address 10.8.15.255. So if you think back to our first week doing networking stuff, even if a lot of this stuff or any of this wasn't here, we should be able to pull out of Wireshark anyway. Just remembering that gateways are typically a .1. They don't have to be, but typically. And then our broadcast address of the 255 there. Tasks for this project: write an incident report. So there's your homework. Write more reports if you want. Completely optional. Based on malicious network activity from the PCAP and from the alerts, the incident report should have 3 sections: executive summary, victim details, and indicators of compromise. So summary, direct terms, what happened, who, when, what. Victim details, he's asking for host name, IP address, MAC address, Windows user account name, and what were the indicators of compromise through IP addresses, domains, and any URLs associated with the activity. He's also asking for SHA-256 hashes of any malware binaries that can be extracted from the PCAP. Hopefully none of this sounds too confusing offhand, but we'll touch on all of that. He's got an answers page here, so if anybody's stuck and wants to go through that, you can get into the answers. It's a PDF file that's also password protected to get in there. So I won't tell you how to. Yep.
Sorry, just to note, the passwords are on the about page.
Yeah.
And he does this all just for learning, like just to teach people who are interested. So there's a lot of Reddits about him and this website, and they all look pretty positive. I mean, people are learning a lot from this, so this is one of the things I liked about it. Anyway, sorry.
No worries. So yeah, the like Kat said, passwords are in the about page, or how to figure out the passwords. So I'll leave it up to you guys if you're playing in this site to figure that out on your own. That way, I'm not responsible for anybody frying their computers here. I've already gone ahead and downloaded these things and extracted them, just so we're not wasting a lot of time. But I'll just show you here. Go into our folder. I've deleted the actual zip files. I've just got them all extracted here. We've got an alerts, which is a text document. We've got a JPEG file, and we've got our Wireshark capture file. If we just take a look at this, this appears to be just a snapshot out of like a SIEM or some other intrusion detection system. I actually sent this into ChatGPT just to give it an analysis, and that'll be one other thing. When you're doing your forensic stuff, don't be afraid to use Google and ChatGPT to try and help you along and get some answers. It's not about knowing every single thing, and that would be impossible to try and remember and know everything. So I even just plugged this into ChatGPT near the end. I tried to do the project without going through this because in our current Lighthouse program we don't have any of this output. We're just going by Wireshark capture, so I did it all with Wireshark first. So we'll circle back around to this, but it does give you some good information. There's a drawing tool here. So something here, binary download file, smaller than 1 megabyte, likely hostile. So it gives you some information. It's going to give us some IP addresses, which are good to know. But again, let's sort of ignore that for now. Just show you the other file that was given. This is our alerts. It's just a text document. Count 27 of this event 6:31. I'm assuming a start time, unless they all happened at that time. I'm not sure. DNS query response name error. Some of this stuff might not mean anything to you. Some of this does mean something to me. Where is it here? Well, we got binary downloads smaller than 1 megabyte, likely hostile. That was also in our screen capture. Some of it spells it out quite directly. Trojan possible. Windows executable sent when remote host claims to send HTML content. Again, in our Wireshark captures, we don't see that. So we haven't really been taught anything about this, unless I've missed something along the way. But again, just an example of what I guess we could see in the future with different applications that are monitoring networks. So if we jump into the Wireshark capture, open with Wireshark. You'll see here we got just over 18,000 packets of information. A little bit of everything in here. And I'm gathering by the interest in this, a lot of people are just, okay, where do I start with trying to figure something out and what the IOCs were. So here I'll call on anybody that wants to throw some 2 cents in. If you've got some suggestions on where to start, feel free. Otherwise, I'm going to sort of start with things that I know and what I would do right off the hop. Yeah, sorry, I hardly heard you there, but I know I think you mentioned about the IP address. Was that from the attacker or the?
Yeah, where they were doing that, where it was saying like it was like identified it as an attacker. Can't you punch in those IP addresses to see how they're correlated?
Yeah, exactly. So that would be a good start. And I don't have that one written down.
I was just asking myself earlier too, like, so you should make like a text file when you're looking at certain things, so you just copy and paste it all.
Yeah, exactly. Yeah, and I guess maybe yeah, I'm getting ahead of myself here a little bit, because yeah, I've done exactly that to a certain degree here. So I've just assembled a text file spot for some other notes. What's being asked for in the executive summary, the victim details, indicators of compromise. So we can fill those in as we go. I've got the traffic analysis alert here. But let's say we don't know that possible Windows executable sent from this IP address. Let's say we don't know about that, or we don't have this file, and we've just got our raw capture. So some of the stuff that I would do right off the start is try and figure out what's going on with the network, my internal network, like the one that we're analyzing, and then what all's been going on outside of that. So if we go to statistics, endpoints, we can get a quick summary of what's going on with the network. We got Ethernet. We can toggle different things on and off down here too. If nobody's seen this section or played with this, you can analyze what's going on with Bluetooth traffic, all kinds of different other protocols that are in here. Ethernet for anything communicating on the local network, IPv6, TCP traffic, UDP traffic. We're going to, because there's nothing in IPv6, we're going to look at IPv4, and we've got a list of addresses right here. So from this, we can actually build our network topology as to what's going on for our internal addresses. If we remember back to week 1, we've got private and public IP address ranges. So if we just do a Google search, local IP address ranges, you'll see 10.series, 172.192.168 series. So we know those are going to be local IP address ranges. So now we can build a picture of the internal network here. 10.8, 15.4, 15.133. There's a 255, our broadcast one.
Why are there 18,000 packets on that third one? That's a lot. That's like 12 megabytes compared to everything else.
Yeah. And so that would be something you'd want to kind of make note of, or consider it as something to look into. So given that we already have, let me just close some of these. Given that we already have a little bit of information, we know that their network is on this 10.8.15. We know the domain controller 10.8.15 is 4. So we can go back to Wireshark and kind of rule out some of this other stuff. 15.4 is our domain controller. 15.133, well, that's the only remaining machine on there. And yes, it's got a lot of traffic going through compared to the domain controller, for instance. So some starting points there. For those of you that might want to get into some fancy stuff here, you can take this list, copy it. I just did it as a CSV. We'll go to a text editor, and we'll paste that into a text editor. Now we got a list, comma separated CSV, all of our IP addresses in here. So now there's different things you can do. You could even take this, go to ChatGPT, for instance. Paste that right into there. Or if you want to also get fancy, you can go and put your coding skills from our Python week to work. Write yourself a little program, or you can copy mine here if you want, and put it to work with that CSV file. And I've already started it, but I'll just show you what I've done. If we remember Python 3, and then I've got this little program that's going to execute when I hit enter here. It's going to take that CSV file, ipinput.csv, that I've technically already saved. And it's going to start scanning everything to see what is suspicious. It's pulled out my local addresses, and then it starts scanning it with VirusTotal, if anybody hasn't used that yet. As soon as it loads, you can plug in an IP address, you can plug in domains, upload files to it, all that kind of stuff. So you could go to, you could plug Google in there, for instance, and see if there's, well, that's weird. Oh. And Google comes back with no known issues there. So that's VirusTotal. With the programming, the Python, there's what's called an API, application programming interface, and through code you can access that without having to plug in every single IP address that we've got. So if we go back to Wireshark and in this list, you could copy and paste every one of these in here and just see what comes back. I'm automating it 2 different ways. We've got ChatGPT doing its thing right here. And if we scroll down, what does ChatGPT tell us? Based on the provided IP list, several things stand out as potentially noteworthy. It's told us about our private ones, and it's told us about our broadcast addresses. And if we continue to scroll down, my prompt wasn't good enough for it. Which it's going to make a liar out of me today. This worked the other day. Okay. It's not going to work for me today. It actually came up. Sorry, go ahead.
I was gonna say, if you still have that chat from yesterday, you could just go through.
Yeah, I'll have to find it. I use ChatGPT a lot, so things disappear fairly quickly. If we go back to my Python code that's running, though, we're checking every one of these IP addresses against VirusTotal. So we can already see, again, the local ones that were just quickly cleared. It's running this one, nothing suspicious about it. Gets down to this 72.5.4329. In VirusTotal, it comes back as malicious. Some other ones here of concern. These are just different amounts of. Let me just run one here. So those numbers represent the number of positive hits here. Some of these are saying it's clean, some of them are saying it's not. So you can see the number 16 up here out of 94 that are checked. And that's what my little program is doing here. It's telling you 16 hits, 1 suspicious, and so on and so on. So I already ran it before we started the call here to get it completed. It goes kind of slow because VirusTotal lets you do 1 every 15 seconds through their API, so that's why I wanted to start it. So we've got 5 local IP addresses, 70 total ones discovered, 4 malicious, and 4 suspect. So we could go through the list and look in detail like we've already done with our 72. And like what was suggested there, and Grubel, you mentioned it right off the hop, was we've already got that report 72.5.43.29, so we could start there, and that's exactly a good starting point. I just wanted to show you through. Go ahead.
Yeah, this is still more. This is still more than we've ever seen. So thank you.
Oh no, cool. No problem. We'll keep going. But that's, like I say, that's sort of where I would start with just that PCAP. We don't have any of the other information, and that's why I kind of wanted to ignore that other little bit for the start. Where would you start? And this is what I do, is separate out the local network, see what's going on with the rest of it. If you wanted to, you could certainly go in here then and further filter. Okay, number of packets, 10.8.15.133, we know that one. Well, the next biggest one is this 72.5.43.29. It doesn't necessarily have to be an indicator of compromise yet, but it's a good starting point. Same with 104.21.55.70. And this is where you'd just start making some notes down. Okay, we definitely want to check out 133. We want to check out 72, and so on down the list. If you've plugged these into VirusTotal and you're getting red flags like so, you definitely want to put a big asterisk beside them and further check into them. In the case of my little automation here, I'm going to completely ignore the ones that don't have any red flags beside them. And I was just concentrating on anything red or suspicious. Back into Wireshark here. Just give me a second here. I made a bunch of notes and I just want to try and cover everything that I felt was important to show you guys. So back into Wireshark. We'll close this for now. We've got our blank screen, or not our blank screen, but our main screen back up. So if we wanted to start doing our research on those IP addresses, we can just do IP ADR equals, it's not going to autofill for me. So now we can start diving into some of the interesting stuff here. We know this came back as a red flag. So we can pull this one up, see what's going on. That's not necessarily a good, well, it's a starting point. It isn't necessarily going to give us all the answers we want, but we can start looking through that for sure. We can see here there's coming from our .133 machine going to this malicious 72 address. There's an HTTP. There's something here /data/ bunch of hex characters. So we can look into here, see what's going on. We can start to open up our different information. And what's this down here? Full request URI. So something's been requested from this malicious site, data/0f. So that would be something you'd want to make note of. And we could certainly do that. We can copy the value, go back to our notes, indicators of compromise. We'll just stick this down here. We're not too sure what that is yet, but we'll just make a note of it. And you could go from there. You could certainly start diving into things further. If we wanted to, where's our GET request? Right here. We could also go right click, follow this stream, this HTTP stream, and we'll assemble all the packets that came in with that request. Is everybody good so far with what we've found and sort of the direction we're heading?
Yes. Can you just read what you just did right there? How did you get to this page?
Sure.
How do you click?
So if we see a request that's collecting information or getting information, and that's sort of the key word right there is get. There's in web traffic, HTTP, for the most part right now anyway, there's get and put requests or post requests. So if you see something that's a get request, and let me just see if it shows that in here. This is just the response to there. But if you see things that are get and put requests, you'll want to pay attention to those. In this case, the source, this 72, is sending back to our 133. So in a minute or two, we'll see the request from 133 grabbing that information. So this is just the response right now. HTTP 1.1 200, meaning it's okay. It was there, it was delivered. So what I would do in this case is right click and we go to follow. And because we're on HTTP protocol right here, we'll follow the HTTP stream, and this puts it all together. So this is showing the entire conversation, 159 kilobytes. So this essentially looks like gibberish, but if we scroll back up here, a little bit about what Jake was talking about today when we were looking through FTK Imager, there was those file signatures, and then there's also different components of programs that you will see in plain English. So in this case, this program cannot be run in DOS mode. So that should be not necessarily a red flag because you could have downloaded something legitimate, but it's something to pay attention to. Seeing that our 72 address is malicious, we want to really pay attention to this. Up in here, some of this stuff here is that file signature stuff that was talked about earlier too there. So once you get to recognize some of the characters, things will stand out. So we're just gonna.
Just to ask.
Yep.
It not running on DOS mode. Why is that something to be wary of?
Sorry, what was that?
Why is it something to be wary of if you can't run it DOS mode?
Because it could still be a Windows executable. It could be a DLL file. It could be a variety of different things that would still execute.
Can I ask you a question?
For sure.
I just wanted to know quickly if you could rerun just very quickly over how you got to, I think it was the Wireshark endpoint, how to save that as a CSV, and also I think I saw you running a script, so maybe just the GitHub page on which that script is found.
Yeah, for sure.
That'd be possible. Thank you.
So statistics and then endpoints.
Great.
And then, like I was saying earlier, you could toggle these on and off depending on what you want. So if you're dealing with Bluetooth, again, there's no Bluetooth in there, so we can just check that off. Ethernet, technically, we can check that off too. We're not worrying about it. IPv4, let me just turn that off. So these screens actually work together. So this is kind of good to jump back to it. So I had a filter running here in the background. And when I go to the endpoints, only those two endpoints that are in this screen are shown. So we want to just turn that off if you don't think it looks right. So here's our full list. We'll just copy that. In my case, I'm just using a CSV. We'll dump that into a text editor of your choice, whether that's like Windows Notepad or I'm using Sublime editor here. And there's your CSV file. Hit save and it's all done. Let me see where my chat is here. So if I go to my GitHub page, so there's a link to it in chat. So this actually came from, I forget how I found it, but I found it on this other guy's site, GitHub site, and I've modified it. I just made it a little fancier with some colors and whatnot. My API key is not in there, so you'll have to sign up for your own API keys, but they are free.
Fantastic. Thank you.
Not sure if there's much else I can talk about it. It does create an output file as well. I added in like the date and time that the thing starts and ends at, just so a person could easily copy and paste this whole page and more or less have a report, you know. So, and then the summary, I added the summaries, cleaned up the formatting and whatnot. So if anybody does want to play with it, just let me know.
It would really be cool if we kind of compiled like a list of commands in Wireshark. I know they're out there, but just ones that are like, maybe these are like the top 5 to go to start looking at things. I can't remember them right now, and I know I've got them printed off. I've got cheat sheets, but I'll try to maybe put something together, and if anybody wants to add to it, they can add to it.
Mm-hmm. Yeah. All right, so let's just continue on here. So everybody was good with the following this package, were they? Right click and then select follow. You'll see our OK, everything transmitted fine. We know it's a program. It's an executable file of some degree. And we know there's a bunch to it, 159 kilobytes. We just don't know what's going on there yet. So it's something, like I say, make a note of. We don't know that it's an issue yet. We can suspect for sure that it is because we've already checked this 72 IP address. Had we not checked that yet, we wouldn't be running any filters on 72, but we could certainly go back and start diving into some of the other stuff, whether we go one by one down the list. You could do it that way. You could start filtering on HTTP protocol. So if we go HTTP in here, we know the exercise is all about malware. So we know that, I shouldn't say we know, but we can safely assume that the person's internet connected and the malware is coming from a malicious download of some degree. So we can filter on HTTP traffic, and we can just start going down the list and looking if we wanted to. HTTP here, partial content, we can skim through here and see what it looks like. And you can start going down the list until you essentially see something that looks out of place. File streaming service, what's this all about? Files / here's a bunch of characters. File streaming, HTTP connection, user agents. The user agents, if you're coming across that word, and it's actually in the one of the indicators of compromise in the report was about user agents. So this just spells out more or less the name of the browser that the person's using. So if you wanted to see what was going on here, like here's a GET request, we can follow, see if this tells us anything. GET file streaming service, files / a bunch of characters. We don't know too much about it yet. You could make a note of that if you wanted to and investigate it further. You could say, okay, what's this IP address, 199.232? You could plug that into VirusTotal, for instance, and do a search on that one if you wanted to, just to rule it out. It's clearing our list. So again, this is just another way sort of going through it. TCP, here's another HTTP request. Look through, nothing too exciting, and so on. You can continue on down the list doing it that way. Actually, I've lost my HTTP filter. Connection test. If you don't know what connecttest.txt is, by all means, stop and throw that into Google. See if it's legitimate. This signature indicates Microsoft Windows trying to download the text file to determine if the internet is up. Doesn't sound too suspicious. If you had concerns, you could certainly plug the destination IP into VirusTotal, for instance. Another GET request. GET requests. I said before we jumped to look at that file streaming file, we could continue on down the list. Here's our 72 address again. What's going on there? There's our request URI again with that string of characters. What else have we got? So we could continue on down the list if we so choose and wanted to do things manually. What's going on here? A bad request. But it's just assemble stuff that looks kind of out of place or suspicious to you. Again, that's more doing it manually. We've already got some valuable information from both our endpoints, just looking at our IPv4s and the number of packets. We can go through that way. We can start manually plugging IP addresses into VirusTotal, getting some alerts, all that kind of fun stuff. Let me just see here. All right, so one thing I did want to point out, and we sort of touched on it at the start when you had mentioned there, Kat, with regards to 133 and all the packets. So if we did do a bit of a search or a sort by number of bytes, for instance, we see our 133 has got a bunch of stuff going on. So number of packets, we've got our 72 with the next number of packets. So this doesn't necessarily mean it's a compromise like we sort of talked about at the start. Just things to research, areas of concern to point out. Definitely if we plug this in because we're like, okay, well, why has this got so many packets compared to everything else? Plug that into VirusTotal and see, okay, malware. There's your red flags that are sort of all coming together and saying, okay, 72.5.43.29 is an area of concern. So we plug that into our notes just to have a further look at. Copy. Okay, so I've touched about that section. Another interesting section that a person could even start with before we start diving into a lot of this stuff. We talked about the endpoints, which is a good starting point. At least I think so. What we've also got is objects. So we can go down to File and then Export Objects. We can go through some of these different protocols. The one that largely we would be after is FTP, but there's nothing there. So FTP is File Transfer Protocol. Not used super often anymore, but it used to be used quite a bit. HTTP, so we'll sort of circle back to that. You've got this IMF, SMB. SMB is sort of a protocol for file transfers on your network. So a few files that are being transferred internally. So you can see this win, jeg, such and such. So this was the domain controller, just talking to the different systems here. And it's got the different file names that are being transferred around. To me, nothing looks out of place with this. These are just system files that are being communicated. What you could always do, though, is you can click on one of these. And this is what's nice with Wireshark, is it ties things together. So if we click on one of these, you'll see the window in the background switch to that packet, or where that packet starts. So we could look at this now, read response, and we could always follow. We'll see if this works. And we can see here the file details that are being transferred, the different headers that are getting all put together. So it's coming from our domain controller. There's the name of the system that it's on, and just the data that's there, 49 KB worth. You can scroll through it if you want. It doesn't look too exciting. Nothing stood out to that to me. But if we go back here again, export objects, and let's just go to HTTP.
Sorry, if you went back to that file you were just showing.
Yep.
It said password history. Somewhere up there we were scrolling. What you searching?
Was it dotted though?
Yeah, it was like yeah, somewhere around there. Maybe a little lower.
Password age. Password history.
Yeah, yeah, password history stuff.
Yeah.
Why is it, is that suspect or?
I wouldn't say so. This is I'm assuming just the Active Directory, the domain controller passing around the information it needs to. Like I don't know. I'd have to look these up to see.
For some reason I thought it was someone making an inquiry.
Yeah. It, the best thing I can say is I don't know. It's coming from the domain controller. It's going to our destination. So what we could do is make a note of that packet number, for instance, and the date and time. And then we've got, okay, what's happened here? Why did it happen then? And then if we find some more details about the malware, we could put it together. Okay, did the malware even hit at this time? Like, did it happen before this? And then the malware is maybe trying to access something it shouldn't, or did this event occur long before the malware did? So then we know it's just. Sorry, I'm losing my voice. If it happened before the malware infection, then this would just be normal traffic, sort of thing. Does that sort of explain it? That's my thoughts anyway.
So we're kind of like using a lot of timeline to see where everything has access to when, if it even kicked up in the BIOS yet, when the system started, did this process happen before this process happened?
Correct, yeah. And so I don't know, I don't think I made note of the time on this one. Let me just jump around here a little bit. So I'm doing this on my Mac on a Windows VM, and I'm getting myself confused with what keyboard shortcuts are which. Okay, so here's our request from that 72 address, and that happened on 8:15 at 12 minutes after midnight. So if we went back, now I've probably lost where the other one is. I've lost what our other file was. Somebody help me out. So we were into the files, weren't we? Export objects, HTTP. Did we get to? No, we didn't get to that one yet. I've gone and lost my train of thought where we were just at with that one rebel.
It was one of the lower ones.
Yeah, I'm just trying to remember how to get back to that. I've gone and gotten lost with where we came from there, Rebel. Sorry. we come across it again, we'll take a closer look there. But the idea is assemble those timelines. We had that one GET request. Of this particular file here. So we want to make note of our date and time just to keep track of it and then build that timeline. So this one here, the initial HTTP request at the 11:58:59 hour type thing. So where I wanted to go though was what I consider another starting point. We can do the endpoints, or we can come over here to files because we know it's malware. So we talked about the some of the different protocols. We touched on SMB. I think that's actually where we found it here. Did we just go to the first one? Okay, yeah, here it is here. So if we look at the timing, 9:47. So that's before that GET request. So we can probably rule that out as an issue. This is just the domain controller, the .4, talking to this desktop PC, the .133 here. So just based on the timing, I would typically rule that out.
Thank you so much.
No problem.
Seeing it such a, it's a big.
Yep. Yeah, no, definitely a good question, because when you start seeing certain keywords and commands in there, yeah, it certainly stands out. So I didn't notice that before. I just dove into objects, HTTP, because again, we're sort of looking at malware. We're being concerned with malware, and we're probably going to guess that it's coming from the internet instead of internally here. So first thing we see out of this list, msftconnecttest.com. Again, Google is your friend. MSFT Connect Test. Reddit posts here. What is it used for? Connection testing process for the internet. We're probably okay there. So moving on. Quote.checkfedexexp.com. It says content tight application. We've got something called management. This is the file name, managements, question mark, bunch of characters. So that's basically just a URL that's getting passed through for a file name request. But right off the bat, I'd like to think that just about anybody here who's worked in an environment, or even just your home machines, when you get your spam in, like, you're checking the email and the URLs and the file names that are all coming in, and okay, what makes sense, what doesn't. Check FedEx. So FedEx kind of makes sense, but what's all this other quote.checkfedexexp.com? What's that all about? So we can copy that. Well, we can't copy it, but we can go write it down. Check fedexexp.com, because it looks suspicious. At least it does to me. If it doesn't to anybody else, certainly let me know, and let's figure that out. But we can go to VirusTotal, for instance. Whoops. Check fedexexp.com. Oh, look at this. Malicious. Everything's coming back malicious. Security warnings flagged for this domain as malicious. We can start going into some details. Suspicious, known infection source, phishing and other frauds. We can get some associated URLs with it. Some of their DNS record information. Who is, look up about their where their domain is hosted, all kinds of other information here. Relations, different versions of what they're using: assistance dot, Chrome dot, check dot, edge dot, business dot, quote. There's the one that we're using right there. Again, it's coming back malicious. Some associated IPs. So here's where you're going to make some more notes. 104.21.55.70, and your 172.67.170.159. So there's a couple more IP addresses to check. We could plop those into VirusTotal, see what comes back. Oops. This one comes back clean. The other one comes back, scores 1 on malicious under this criminal IP check. So we could go into some more details, see what other people have found out about them and whatnot. Just in the sake of time, I don't want to tie up everybody all day here. So I want to get to some of the good stuff here. So just because it's kind of second on the list, we'll dive into it a little bit deeper, but we'll just skip through some of this other stuff. We got some Microsoft.com domains. Those look legit because Microsoft.com. We've got the IP address. We've already identified that as suspect. It's come back in our VirusTotal check as malicious. So if we scroll down, we can see here something's gone on here with a file. 159 kilobytes. So we saw that when we followed that one stream, and more from this address, quite a few from this address, just little bits of traffic that are being transferred. Something here, again, Microsoft, so we can ignore that. So here's where it gets kind of interesting. And let me just catch up on my notes here. Okay, so is everybody comfortable with saying our attack has occurred on this 133 at this point in time? Does everybody sort of see what's gone on here? For one, it's the only computer remaining when we rule out the domain controller. It's also heavily communicating. If we go to ip.dst, because we know our malicious website of 72. Why is it not filling for me? So we know here we're filtering on our malicious IP address, and the source, it's coming from the 133. It's reached out to this malicious IP address, and one of the first things that happens is we're getting this file sent to us. So again, anybody doesn't agree that we've got an issue with 133 as our likely victim?
Could you explain it again, Ernie? Because still, like, it was like not so clear for me.
Okay.
Yeah, so thank you.
Yep. So if we're just starting right from scratch again, statistics, endpoints. We've built a picture, whether it's in our head or whether we've scribbled it down on paper or however you want to do it. We've built the picture of our local network. So we've got 4 machines here: 15.4, 133, and 255.
Yes, yeah.
.4 was already said that it's our domain controller. Now, if it was connected to the internet, we could have a problem there. If we come back here and just to sort of narrow that down, if we go ip.adr equals 10.8.15.4, we'll filter all the traffic on that machine. So here's a good way of sort of breaking it down. Now, we don't necessarily want to go through 2,000 records, but if you did you will see, let me just see if I can narrow it down. Source. So we're going to take the source, which is our domain controller, and we're going to filter, and we're not going to filter, we're going to just sort on our destination IP addresses. And you'll see the only thing it's communicating with, aside from the broadcast system, the broadcast address, is our own internal machines. 133 and coming back the one, well, 133 to 4 and dot 4 to 133. So right there we can see that our domain controller is only working internally right now. So that kind of helps sort of split that down. Our only one remaining machine is 133. If we come back to our areas of concern, exporting objects, HTTP, if we click on this check FedEx, for instance, this is an area of concern because, again, that doesn't sound legit. We've plugged it into VirusTotal. It's come back as concerning. So if we click on that, now we've created a filter based on this packet number, or if we go onto this packet number and we close. Here's our destination address, our 133. So something happened here. We've got HTTP traffic on it. It's 200 OK. It's requested a file. So again, everything's coming right back to this 133. Does that that kind of helps? Okay.
Yeah, I got it. Thank you.
No problem. So just to jump back here, again, this is one of my starting points, sort of a second starting point aside from building our network, is going to files. Second one on the...
Just to clarify, in that background, what you were doing is also to clarify if it actually made contact with that notorious IP address that
Yes.
you already had.
Yeah, exactly. So.
And was there a way that they showed us that you could actually filter the source and the destination IP address at the same time?
Oh yeah. So if we just come up to our filter bar, IP.source. So here's one that I've got right here. Source, the .4 address, and then the IP.dst for destination. And we put in 133, and that'll just filter on those addresses. If we wanted to change this to one of our, let's go here for source 133, and what's one of our malicious IPs? Whoops. So there's a filter working on both of them. We want everything with a source of 133 and everything with a destination of the 172, 159. And there it is, all filtered. Sorry?
That was one of the, that IP address, the 172, one of the malicious ones that.
Yes, that's right.
So this IP address 133 is making that. And this we could just take a snapshot and prove it correct for our, I guess our reports.
Yeah, you could. Yeah. And then it's assembling timelines here too. Like, no, don't forget, like with all the jumping around that I'm doing, a lot of this I'm saying is my starting points. So there's what I've got is two major starting points in all this: the endpoints, so I can build the network topology, if you will, and what's happening outside of the network. And then another starting point that I like to go to is this export objects, HTTP, to see what there is for files. And going into this, we're actually seeing right off the start something malicious. We've checked this quote.check FedEx because it doesn't sound right. It doesn't look like a legit FedEx website. And that's what I get when I see FedEx in here. I'm like, okay, FedEx quote dot. Well, that kind of makes sense, but what's all this other stuff? So that's why we kind of plugged that in there. We got a file transfer. And
just like how you put the malicious emails, you know how they try to mimic the actual websites.
Yes.
Like little very through it.
Yep.
So that's what we're looking for.
Yes. Yep. you don't necessarily have to look for that. But when something like this stands out, like to me, this screams red flags. Maybe because I just pushed out a couple weeks ago a broadcast to the one company that I do freelancing for, saying basically watch for malicious, emails, and I ran an anti-phishing campaign the same day that I pushed the email out, and I had one guy fail, but not too bad out of 120 people, I hope. But it's things like that, like that screams red flag to me. I'm not sure how everybody else gets for junk email every day, but I get a few of these things. They slip through the filters, and you just hit delete on them and move on, sort of thing. So it's look for all these things that might be suspicious. They might not be suspicious to you. They might be suspicious to me or someone else, and that's where that whole puzzle thing comes in together. Work on what your strengths are. So this is where my strengths are. Building that network topology, seeing what's going on there. My Python coding, to me, that's super quick and simple. Plug that into my little program and let it run its thing in the background while I have a look elsewhere. And that's what brings me to sort of my starting point, if you will, part number 2, which is this file, the object list. So to me, this one stands out. The other ones we had a quick look at. They're Microsoft domains. They don't. We've already got a red flagged IP address with a bunch of little files going on here. So let's just have a closer look because it's next in the sequence after this Microsoft test. Packet number 8659, quote.checkfedexexp.com. So if we just move that out of the way, clicking on it takes us in the Wireshark captures. Actually, I've got a filter running. Clear your filters, export objects, back to HTTP, check FedEx. It takes us right to this package. So we'll just close that again out of the way. We can look a little bit more. Like I said, we've got this other IP now that we've already made note of. It's coming from here. It's going to our 133, our local machine. It's been a file transfer. We can follow it. Host quote.checkfedexp.com. That's one of our questions we need to answer in our list. Indicators of compromise, IP addresses, domains, URLs associated. So we could copy and paste that into there. Back to Wireshark. We can scroll through this a little bit. What's this here? Attachment. So this looks like it'd be an email that came in. There's an attachment. There's a file name, invoice 876 Okay, probably sounds reasonably legit to most people. It's an invoice. There's an invoice number. It's a zip file. Maybe that doesn't make sense. But again, to me, that kind of is going to raise some red flags because most people in big business are typically too lazy to zip stuff. They would just send the PDF and be done with it. We can continue to skim through here a little bit more to see what's for red flags. So it says .zip. Here's our email signature right here, PK. That's for PK zip. You'll start to recognize some of that stuff. I wouldn't expect most of you to notice this, but you'll see English words here. Invoice 876, that matches our file name. We keep reading through here though, then there's another dash, some more numbers, .js. To me that stands out because I do programming. JS is typically JavaScript. So to me I'm like, okay, why is there a JavaScript file inside this invoice zip? That doesn't make sense. So red flags, start writing stuff down or making a note of that. You can scroll through all this stuff. You might spot some interesting words. Probably not if it's zip because it's also adding that the compression is sort of creating an encryption to it as well. So you probably won't see too much until you get to the end. You'll probably see some more plain English. Here's that file name again, .js. Here's the closing signature of that file with the PK on there. So it's like, okay, what's going on? We followed this stream, 2,700 kilobytes of data. What's that all about? let's have a closer look. So we'll go back to File, Export Objects, HTTP. This is where stuff's going to get interesting. You're going to want to, and let me jump around here on us, make sure at this point, if you haven't already, is make sure your system is isolated, because we're going to get into the good stuff here. So ping google.com. We know we've already got internet access. Not the end of the world. But if I go ping 192.168.2.175, this is the server on my own network at home. Typically, I don't want to see this, because this means our virtual machine is able to see my home network. Not a good thing when we're diving into malware. Now, it is isolated further, and I did do all this testing completely isolated on a dedicated machine that had no access to it. For those of you that have followed the Home Lab little series we did, knowing your router, a good place to start is your guest network. If your router offers a guest network and you're not using it for, let's say, your IoT devices, that's a great way to connect a spare computer, let's say, in an isolated way away from your network. So make sure you're isolated. In this case, it's technically not. It sort of is with firewalls and whatnot, but this is a really bad sign for what we're going to do next. And this gets into our discussion with the can Wireshark infect your computer? Sorry, was somebody trying to? No, okay. So in that compass reading that Kat pointed out there at the start, can Wireshark infect your computer? The answer is yes and no. What we've done right now is pretty benign. Nothing too exciting here. The next step, we start to raise some concerns, because we're going to have a look at this file, and we're going to extract it out of all that jumble of code we saw on the screen. We're going to make a file out of it. We're going to look at it. But just because I'm saying here, my virtual machine can see my home server, doesn't mean my home server can be infected. You'll remember in some of our lectures, just because we can see it, we have to have something there that's a vulnerability, a weak point for it to infect or to get through. So if I went through and I did my ARP scans to see my other network devices and my Nmaps to see what's vulnerable, it's going to come back pretty solid, just with some internal firewalls going on. So I'm not too worried, but if you had an open port with a weak piece of software on there, there's your vulnerability, if you remember a few weeks ago discussing those things. If Wireshark itself is an application that's running on this computer that we're investigating from, what happens if Wireshark has a vulnerability that's a 0-day that hasn't been identified yet, except by somebody with malicious intent? They might say, okay, we can send a certain piece of data down the Wireshark, down the network, that's going to trigger something in Wireshark. So yes, you could have an issue. That's why it's important to do your isolation when you're looking at all this stuff. But let's get right into some of the good stuff here. We're going to export objects. We're going to go HTTP. We're going to go back to this first file. And if you're following along, if you're wanting to answer those questions in that exercise, click on this, get your date and time. What happened? 2024-08-15 at 11:04 from this IP address to this one. This is our first indication of an infection occurring. We're getting details. We're getting a file from this website. It's coming down the line to our 133 machine, and it's been a successful download. So make note of that time. What we're going to do in our HTTP object list is we're going to save on this file. So we click on that line, we hit save. You can use the default name if you want. and it was, or if you remember back, it said something about invoice and a bunch of numbers, and it was a zip file. So we're going to continue on with the .zip, and we're going to hit save. We might as well just close out of that for right now. We'll go into our terminal here. Downloads. Where is it? Here's our file, 2.7 megs, or is that kilobytes? Be very, very careful, .zip. We'll just open our file explorer. Here it is as a zip file. We're going to right click, extract, and we'll put it in this folder. Be very, very careful folder, and we'll hit extract. Here's our folder. Be very, very careful. Here's our invoice file, and it says type JavaScript file. Continuing to be very, very careful, we want to have a closer look at this thing. So we're going to open. I'm going to choose a different app. You definitely don't want to double click. That will execute the file. It's JavaScript. Windows has a built-in system to run your JavaScript stuff, so do not double click. And this would be, I'm not sure everybody's comfort level with where we're at right now, but what are we, sorry, I'm missing all these chats. I don't have the chat side open, so if anybody's got something going on in chat, let me know. Just to confirm, you can put malware in.
They were mostly like bantering. This is super exciting. Should we set up syslog on Windows before we do this, if you're actually going to execute it, or maybe for another session?
Yeah, I'm not getting into any of that stuff right now, but yeah, you could certainly play around and see what that might offer. So JavaScript, JavaScript is basically text-based. It's like our Python that we're doing. What you see is English, and then when you go to run it, it's interpreted by, in Python's case, the Python interpreter. Other ways of running programs are like exe files on Windows, and those are compiled. So there's two different types of programs. They're interpreted and compiled. We won't get into details, but JavaScript is interpreted. So when we go to open this, we should see some plain English. I'm just going to hit just once on there. I'm using my Sublime because it's going to give us line numbers. It's going to make things look a little sort of pretty. But this will be some good stuff here. Hopefully not too confusing for everybody, but I'll point out a couple of things, hopefully fairly quickly, because I'm going through a whole lot of time with what seems quite quickly here. So we got a pretty big file. Lots of stuff going on here. This is it shrunk down on the right-hand side. You can see if I scroll through, it's all grayed out. But this is Sublime is an editor that also figures out code for us. And you can see some stuff that's in colors just to identify things that are going on. So similar to Python, we've got functions. Now all of this doesn't look like it makes sense, but I'll try to make it make sense here shortly. So here's some stuff that actually, yes, does look like code. And we can just continue to scroll down. There's a lot of stuff that doesn't make sense, like Fortran 2008 bindings with the MPI FO8 module. That doesn't make sense. Why is this in an invoice file? This should all raise red flags. Doesn't make sense to me. Hopefully it doesn't make sense to anybody else. I was reading something. There was something in here about climate change. There's, what's this here? List all figures, all named constants with the exceptions noted below for Fortran. Why are they talking about Fortran all of a sudden? This is supposed to be an invoice, right? So scrolling back up here, what's going on is this is obfuscated code. If you start to know, well, if you remember Python, there's ways of doing comments in your code. And in JavaScript, it's no different. We can have comments in our code with these slashes and a star. There's other ways too. There's double slashes. But in this case, we can identify this slash with a star, and that's a comment. If we go view, I'm just going to turn word wrap on here. Here's one big line. There's no slash and a star, but it also doesn't make sense for it to be a program code. But if we scroll down, and I'm going to do this for the sake of time, I started going through this, just trying to find details and removing comments. And if you wanted to get into malware analysis and reverse engineering, something like this is a good thing to do, but time consuming, because we want to start taking all these comments out. Slash star, here's one here. You want to find the end of that. So a star with another slash, here it is here. So all of that stuff that's highlighted is garbage as far as the program goes, so we can hit delete. I'm just going to continue on down to the point of interest. Otherwise, we're going to be all day and half the night just going through this. Here's a bit of something that looks legit. Function, bunch of characters. This should sort of make sense to us with what we've done in Python. You know, this is a function, this is a function name, and these are arguments getting passed into that function. So you would want to stop here and say, okay, why would anybody in their right mind use variables and function names that look like this? Like here's variables, var, var. Who's gonna use this variable name? Who's gonna remember this when they're writing their program? So again, red flags, what's going on? Continuing on down, more gibberish. But because these are all comments, if somebody was to double click that file, because these are all comment areas, the Windows system just treats these like nothing, that they don't exist. Let me get to it here. And I'll show you how easy it is for us to strip the comments as soon as I can find the one that I'm looking for. I'm gonna cheat here. So again, I don't want to tie everybody up, but this is one of our lines here. Here's an ending comment section, that's star and the slash. So we could delete everything up above until we find the starting slash star. Delete. Let's just put that on a new line. And let's just work our way through. We'll do a very, very quick reverse engineering here on what this code's doing. So we've got another comment section here. Hit delete. We've got another comment section here. Hit delete. And we got another one. Hit delete. And just a couple more, I promise. And we'll go to there. So now what we're left with is, if I put this one on a new line here just to separate that out, we're left with what looks like a bunch of gibberish, .open, and this GE plus quote quote. Well, if we think back to our programming, we're adding some strings here. Anything inside the quotes is string. So that's nothing. Get rid of that. Now we got 2 plus signs. Let's start getting rid of that. What's this GET? Well, we're just assembling a string. They've used single quotes. They've used double quotes. So let's just make it all single quotes. Get. There's a get request. And it's going to a website. business.checkfedex.com now. Good thing to make a note of right here. Continuing on, they've got some more stuff going on here, another plus sign. So this is just putting these two things together. Again, it's still a string. So we can get rid of that plus sign. It means absolutely nothing to the program. Here's another one, plus 38. Here's another one, plus 8. Ending quote and a comma with this number, 250 minus 1, well, we could turn that into 49 because 250 minus 1 is 49, or 249 in this case. So now we've got actually a legitimate piece of functioning code right here. It's a GET request. It's going to this URL right here, and it's doing something. If that, like I said, if that person took that invoice.zip file, downloaded it, they're not seeing anything going on, they double click on it, no, okay, invoice .js in there. Well, where's my invoice? I need to pay an invoice. It came from FedEx. Then they double click this file. All of a sudden, Windows is ignoring all of those comments that we started to delete out, and it came across this, and it says, get whatever this is from this checkfedex.com site. So you can see at this point, hopefully, how easy it is to infect your computer from doing this analysis. If we weren't very, very careful, we went back to Wireshark, we saw these files, export objects. The first one on the list that looks suspicious, we click on, we extracted it, or we saved it. Then we start opening things up. One wrong double click, and all of a sudden that little bit of code executes. Now there is more code in there, and if anybody wanted to play with it, you're more than welcome to go into it and look further. Unfortunately, there's no real easy way to deal with all these comments. I tried letting ChatGPT deal with it, and it made a mess. They've done a reasonably good job of obfuscating the code in here, burying it in between all these comments. So it's a very manual process. So you could go through, clean out comments. You can go through and you can do a search and replace and say, well, this function, what's this all about? Let's go and do a search and replace on this letter here, or this string of characters here, and make it something more intelligent. You could end up, like I say, reverse engineering their little thing and seeing what it does. We're not going to get into that today because we'd be hours doing that. Like I said, the main thing I wanted to show you was this one line with the GET request, because now we've got another indicator of concern. We won't call it technically a compromise yet, but we'd want to make note of this business.checkfedex.com. We've already got that. We've got a file. So what we can do, where is it here? We've got our file, be very, very careful, .zip. We can turn around and go to VirusTotal. Back to VirusTotal. If you remember, I said we can send this thing files. Choose File. Be very, very careful. It's our zipped compressed file. Open that. Let VirusTotal do its thing. It's getting us a hash value. That was one of the questions in the exercise there.
Ernie, just to ask,
Yep.
what would have happened if you uploaded the actual file and not in the zip form? Would that somehow activated that file?
No. We'd probably get the same answer, just or the same details, just differently. We might get a different hash value, or we would get a different hash value, let's say. What's going on here? I thought that was working. Computing hash, checking hash, confirm, uploading. Here we go. So we're starting to get some results. Malware, whatever this JS Callisto is. So this would be stuff you'd sort of make note of as to what we might want to look at. We can go into some details, relations. Here's our invoice.
Is VirusTotal free to download?
Well, it's free. It's free to use. It's all web-based. So yeah, it's completely free to use online here. I'm not sure if they do have any component that lets you download, but yeah, definitely put it to work. All right, so moving on, we know that this JS file is a problem. It's malware. It's got this Trojan downloader script it talks about. So we know something further is going on here. We go back to Wireshark. And we can build our timeline. If anybody's got to go to, I apologize, I'm taking way too long here for all of this with where I wanted to be. We've got our invoice file that we found. Export objects. This management section. So we downloaded this thing. We had a look at it. It's this JavaScript file with this business.fedex in there that we're not too sure about. I'm just going to sort of jump ahead a little bit. We've already checked our Microsoft ones. They're all good. And it's like, okay, what about this 72.5 one here? What's going on here with 159 kilobytes? Here's this thing here. Let's take a closer look at this one. Save. And we're just going to save it. We won't change the name this time around. We'll hit save. We hit close. And look at right off the hop here. Microsoft Defender found threats. Get the details. See if it tells us something. So you can see in this case, Defender's done something to help us out. Threats found. Start the recommended actions. It's found Trojan, Win64, WarmCookie. It's labeled it as severe, the date and time. What do we want to do? Quarantine, remove, or allow on device. So for the sake of the exercise, we will allow on device. Let's just say Defender wasn't configured properly. That thing is now downloaded and sitting there as an issue. Actually, Defender did take it away. Let's just turn that off. Sorry, back to Wireshark. Let's try that again. So if we followed this around though, we've got our downloaded file, we've got our IP addresses where this thing came from, our 104.215570, and it's come to 133. You will get to see that 133 starts to communicate with 72.5. And that's where this file, this next file of interest comes into play. So we'll hit save on it. I'm just going to leave the file name alone. But again, be very, very careful with it because you don't know what it necessarily is. We've got it downloaded. Let's send it to VirusTotal. File, choose file. Here's our file right here. Open it. It's a little quicker this time around, so it's got 50 hits of something severe going on. We can start reading through malware, generic, Trojan, malware, lazy, backdoor, Second2. So, you know, you could look up each of these if you wanted to, or when you get adventurous and find out what they all might mean. You know, is it trying to create a backdoor to our system, for instance? Here's our WarmCookie name that it's been given, Trojan Win64 agent, and so on. Somebody just coming back with generic and just Trojan Win64. Some of this doesn't really mean too much, injector. But you can do some research at this point, you know, like if we did take WarmCookie, for instance, you know, and just do a search on it. Here's one here, Malpedia. WarmCookie. WarmCookie is a type of malware designed for information theft and conducting malicious activities on infected systems. capable of keylogging, capturing screenshots, and extracting credentials from web browsers and other programs. Obviously not something you want to have running rampant on your machines. So, like I say, be careful. Very, very careful when you're doing this stuff.
Ernie, just
Yep.
to ask, in that other page before, you see how it was showing, not this page, but the other one, it was showing the type of, you see how all of them are registering it to be like different things? One is saying it's a virus, one is saying it's this,
Yep.
one is saying it's a Trojan, one is saying, is it because it's like a compiled program that does a multi-tax of things and they're all just finding different things that it's registering with each virus scanner?
It could very well be. I don't know 100% to be able to answer that for sure. So it may
It
just
seems like one of those programs that hackers have that when it has access to your system, they have like a bunch of tools all
Yeah.
right there. Type
Yeah.
of thing. No? Okay.
yeah, and that would certainly make sense. You know, if it's doing this backdoor stuff and it's capturing screens and keylogging and everything else, that would make sense that it's throwing different signatures for different places that are scanning. You know, so
Like, so could you almost say these are like different exploits compiled into one to just be used? Is
Yeah,
that what's happening?
yeah,
Just
yeah.
different type of
I think that would make sense in how you could describe that. Yep. But these the companies or the places in white here on the left and over here, these are the different scanning services that VirusTotal is using. So it's going through this place called Dr. Web, Cynet, Trend Micro. I saw that somewhere here. Scrolled past it, I guess, because it was a red flag. Trend Micro, Microsoft was in the list. Another one from Trend Micro. So these are just the companies that are scanning that file for us and what they're returning and what they've found. So whether that finds the first thing and sends it back, I don't know. Or the most popular component with regards to it, that's something not that I can answer, but we've definitely got a lot of red flags to watch for. So,
Thank you.
but you could certainly piece together, like, okay, backdoor. Let's do some research on that. Let's look more into WarmCookie through this site here and get some details. So, where are we at? WarmCookie. We've touched on our code. Let me just catch up on my notes here again. We've got our couple of URLs of interest, the check FedEx, if you remember that one. We've got our business, I think it was, .fedex. Check FedEx. We got into our code, and that's where our business FedEx was. So what happened was check FedEx was the file that got delivered to our 133 machine as an invoice.zip. 133 opened that invoice.zip. They double-clicked the zip file, or they opened the zip file. They double-clicked on the JS file. The JS file reached out to that business FedEx, and then it came back and delivered this from 72.5.43.29. It delivered the main payload of the malware at 159 kilobytes in this file that we just sent to VirusTotal. Everybody follow so far?
Yes. Yeah.
Good.
Hey,
Yep.
like, could you repeat those like the last few sentences that you know how this one happened? First, a request was sent, and then it downloaded.
Yeah.
That there was a bit of issue on my side, so I couldn't hear you.
Okay. So going back to the first instance here with this quote dot check FedEx. If we look at that, in our in the main Wireshark component here, and we just go follow HTTP stream. It's accepted down here, content disposition. This just kind of stands out because it's got an attachment and then it's got file name. So this would have been an email that came in from somebody to our unsuspecting user on .133. So we've got the zip file.
Okay. Yeah.
We can, at this point, we can assume they've opened it because they're confused. They want to get this invoice paid. They've opened it. They see this JS file. They might be thinking, okay, well, for some reason it's not a PDF or whatever. It's not my Excel file that I was maybe expecting, but they double click on it. So that's why we downloaded this file from our export objects.
Yeah. And
We
check it
we
with
saved
virus
it.
total,
Yeah, we did a little bit of a dive. You don't need to do that, but if you trace the continuation on in Wireshark, you would end up seeing some transactions back and forth after this.
okay.
And then what happens is that JavaScript file reached out to the business FedEx, and business FedEx sent back to this 133. So we'll just click on that one. And it's got our malware file. Check FedEx.
Okay, so first so just to understand, so the zip file is not a malware. So it is like a request to send to this, like to this some site to get the malware.
Yeah, the root malware. Yeah, exactly.
Okay.
Yeah.
Okay, yeah, got it. Thank you.
Did that answer your question then?
Yes.
Oh, okay, great.
Thank you.
Yeah.
Ernie,
Yeah.
you see that that IP address where the actual malware is coming from? Is that the IP address that gets reported to like the ISPs for them to like knock off that IP address from continuing to do that, like to keep servicing or hosting whatever that file is, or no?
Yeah, it could very well. And then it depends on the ISP as to whether they're going to knock it off or not. But yeah, it could certainly raise the red flags to them and say, okay, what's going on here with this IP address? So.
Do we have to report it when we find it, or do they just do that on their own?
Good question. I don't know. you could certainly dig into it. Okay, like who owns that? Excuse me, who owns that IP address? So if we went back to virus total.
And it was a good question Kat was asking me earlier. If let's say this is happening in a corporate environment, we just knock that IP address from being able to download or upload through a firewall, or do we find the threat actor's IP address and knock him off? But his IP address would change every couple of hours or 20 minutes, so it'd be better for that actual file, correct?
Well, the file name, you wouldn't necessarily want to block that file name, because that file name is probably going to change just as much as the IP address would, because it said invoice dash and a bunch of numbers. So I
where the file is coming from.
Oh yeah, you could certainly do it that way, but you might want to also look at the range of IPs, like where's 72.5.43.29 from.
Oh, got you.
See if that. Actually, it should be in virus total here somewhere. Details. Okay, I thought I saw it somewhere in here, but you might have to do some looking. I saw it at one point, but there's lots of places you can plug that IP address into and find its geolocation. And then you could block, Romania or China or whatnot, unless you've got, obviously, people traveling to those places. But that's one way you can do it. My server back in Calgary, for instance, is open because I VPN into it. But at the same time, I'm not traveling. So like pretty much anything outside of Ontario and outside of Calgary, outside of Saskatchewan for Regina, all those are pretty much blocked, with the exception. Well, most of the states in Canada is open, just because if I'm traveling around, I could be bouncing around in the States with connections and whatnot and still wanting to access my machine. But that's
so if you ever forgot your VPN was on and your connection's coming from the UK, you would have access to your system.
Correct, yeah. But you can narrow it, like I say, you can narrow it down through the settings in the company, or at least I would hope you would be able to, and start blocking some of these. Or you just red flag this IP address and away you go. But there was something in here. There was something that showed us, and now I've gone and lost where it was.
Maybe that little IP right there next to text HTML.
No. Oh, here we go. Here's a country of origin, Romania. And then there was something here, details. Yes, their what's called their who is lookup. So that looks up about their domain. So you can find out who they're hosted by. It was Cloudflare, I saw. So technically you could reach out to Cloudflare and say, okay, that this person is sending malware out. Can you block them? Or just block them yourselves. So whatever blacklist total is, maybe that's a good spot to get a list to plug into a firewall, for instance, and just block everything from it. I don't know. I haven't been here before.
Sorry, Ernie.
Oh, yeah, no
You cut
worries.
out there for a second.
So I'm just saying this blacklist total might be a site to find all the latest places that are,
Ooh,
you know, it looks interesting, might be something to make note of and follow up later on.
yeah.
So, but I
Can
wanted
you put
to,
that site up?
what's that?
Can you copy that list, that site in the chat?
Yeah. I'm hitting the wrong keys. All right, so I just wanted to try and get through a few other things here, hopefully quickly. I still got everybody. I haven't lost anybody too badly yet.
Just a few. Understand.
Because technically we're still on what I consider my starting points, even though we've done a few deep dives. We've got our statistics endpoints for sort of starting point one to build a network topology. And we've got file, export objects into HTTP to sort of build a second starting point, because you could certainly start here too and say, okay, well, what's going on? Check FedEx, looks suspicious. Let's do a deeper dive. And you could approach it that direction. Okay, we've extracted some files. We've spotted some stuff that we shouldn't play with, but it's kind of fun to play with. And we've got a list of different IP addresses. So if anybody wanted to play with answering questions, build a list of your different IP addresses that are going on that are all suspect, and sort of research all of those to see what's malicious. We've got our timeline. I didn't write anything down here, so hopefully somebody was making notes. But again, if we went back to export objects, our first suspicious activity right here on packet 8659, we can click and we get this 0815 at 1104. This is when the request was made to get our first malicious file, which is that invoice zip. Then what's happened is invoice zip ended up getting opened and it's starting to communicate. It's grabbed our full malware package. That happened at 8:15, 12 minutes after midnight, from this IP address to our suspect person. So let's find out some details. Who is 10.8.15.133? Because those were some other questions.
The 10.8.15.133, he is the user, right?
Yeah, that's correct. Yep. So if we just do a search at this point, IP address, we can start to see what's going on from this guy here. And we can try and determine who this person is. So you'll just see different communications going on. You can just start to look through them, really, and certain things will start to stand out right off the start. One of the questions in the exercise was the host name. So right here we've got desktop dash h8alzbv dot local. So that's the host name. It's communicating with the broadcast system there, with the domain controller. Let me see what else have we got. Some of the protocols, I don't think this one was really talked about too much, if at all. But LDAP is a good one to remember. So if we combine our filter on LDAP, that's a network communication protocol. And why is that not working? So LDAP, a network communication protocol, we can see the domain controller, the .4, communicating with the user 133. So we could just take a scroll through here and try and see if anything stands out. Some plain English down here. Talks about our domain controller name. Something to watch for, bind responses or bind requests is what I'm looking for. Bind requests. See if we can find something interesting in there. And some of this stuff just comes from experience. So again, I wouldn't expect everybody to know, okay, LDAP bind request, I'm going to go straight there. But we might find some information in here about who this person is. We might not.
So your experience with mind control, like you dealt with this before?
Yeah, I've had to deal with some of this stuff, yeah.
Okay.
And just with the networking as well that I've had to deal with, so. Because, I mean, Wireshark just isn't for finding malicious actors. It's just identifying what's going on the network, really. It's watching that traffic. Okay, I'm hitting dead ends there. Okay, so I've kind of hit a dead end as to who this person is. So we'll just go back to 133 for a minute. One of the other questions is what their MAC address is. So that should be fairly easy to find in here. Just gonna clean it up with some HTTP traffic. If I opened the right protocol here, I'd find it. Source. We're looking at our 133 machine, our source under the Ethernet protocol, 001CB4 82. There's our person's MAC address, our identifier of their hardware. What else have we got going on?
So Ernie,
Yep.
This is how people, like, when you make a connection with someone in a chat or any type of like gaming console, this is how they're able to get your IP address.
Yep. Yeah, it's pretty easy to get those public-facing IP addresses. So here I've just done a search for the ARP protocol, see what's communicating on the network, who has 133, who has .4, and so on. We'll just take a quick skim through to see if there's anything interesting. Doesn't look like it. So at this point, I'm just sort of flailing about for anything that's going to tell me who this person is. Copy, byte says, printable text. That didn't work the way I wanted it to. So this is just their computer name, that H8. It was desktop dash, but I think they talked briefly at some point about being careful about how you search, because some things will get broken up and kind of obfuscated with those dots in between in particular that we've seen. So I've just broken it down. We're just going to use that. See what else we can find in here. Here's our desktop showing up in the text. What else have we got here? There's communications again. There's how it's kind of split with the dots in the middle for making searching difficult. I'm still trying to find like a username. And we're losing everybody too on the call here. I'm taking way too long.
No, I don't think you're losing people, but you know what? We've learned more here today.
Well, and then
Am I
you
wrong? Wrong.
and then you get to see me
So this
fumble
is
about.
good.
You get to see me fumble about here because I forgot how I found the guy's username.
No, I feel bad. You need to have like somebody there, like giving you snacks and giving you water.
and to make notes beside me as I go through here. I had a bunch of notes and I can't read my writing now. But the one thing about username is I didn't make enough notes on it to say how I found it.
Does your dog know how to open your fridge and get you a beer at least?
No, he hasn't figured that out. He can run the ice machine and he can bring me his toys for what kind of food he wants, but he hasn't figured out how to bring me stuff.
That's brilliant.
Okay.
He knows how to cook food.
He's a picky eater, so he's got I think there's about 5 different toys, and they're like an octopus, a stuffed octopus, with the tentacles. So he eats these freeze-dried raw cubes. So they're like a couple inches sort of square with different flavors. So different colors of octopus get different flavors of cubes in them. So
That's hilarious.
depending on what he's desiring, he will bring me the different colored toys. Wrap it up in the octopus tentacles, throw it. He goes chasing it. He gets to chase his prey, pounce on it, then go running off with it. And some days he'll bury it in a blanket for later. Some days he'll just peel it open, and he's very gentle with his toys. You'd think he'd destroy them, but no, he's very gentle with how he opens them up and eats his food out and returns it for a refill or sets it aside for later. Getting distracted here. I'm just
Top right corner. It says source is 5 FPS. Is that normal for everybody? The streaming?
where are you seeing that?
At the top of the chat, like the screen, the Discord. Because sometimes you're cutting out, right? Like in sentences, we're losing a couple of words.
Oh, okay.
I think that's why. It's at 5 frames per second.
Is that happening for everybody? I don't see.
I also had the same issue, so that's why I was asking you to repeat.
Oh, okay.
Yeah.
I don't see where we're getting. At least on mine, it's not showing me. Oh, up in the top, there it is. Streaming quality.
Next to live. Mine's showing 5 frames per second. I was just curious if everyone was getting
Okay.
it.
I'm having that as well.
I might have to look at some.
I'm still stopping.
I'll have to look at some settings for next time, or I'll take this to Zoom or Google Chat. I'm cheating here, guys. I forgot how to find this guy's name, so I'm going to cheat and we'll sort of backtrack it. Backtrack. Okay, it is in LDAP. There is communication in LDAP that I've clearly missed. I know why. Cancel. Filter LDAP. So again, popular networking protocol here. I was too busy looking at stuff that didn't really need to be looked at. But right in the info lines, we will start to see some useful information. Search requests, the domain controller name, and we can continue on. First name, site name, and just continuing on. Again, more about this domain controller name. And so for me, a lot of this in Wireshark is still very manual. There's the page that this little WarmCookie project came in on, had some good information about setting up your Wireshark with different filters, or not filters, but different columns. One of those that I saw was about extracting what's called a CNAME record and putting it into the column, and that would actually give us the username. So here's something here, LDAP, search request, Pierce Lucero. So if we went with this and we went to edit, find packet, we want packet details. We want to search basically everything that we're seeing. We're going to search wide. And if we just searched again on Lucero, let's take off our LDAP packet, find, and see if there's anything interesting here. Find. Right off the first one that comes back, P-L-U-C-E-R-O. We're searching on the guy's last name that we found in that LDAP packet. So it's found this P-L-U-C-E-R-O. The first name, I forget, what was that, Paul or Pierce? So that would make sense for a username, first initial, then last name, P. Lucero. If we keep searching through here, you'll end up finding it actually spelled out. Lots of the Lucero for the username. And here's a record that makes it look like it makes sense. Lucero, Pierce Lucero. So there's our person's name. And again, part of this was experience with the LDAP packet searching. And then some of it just came down to, okay, what What can I do next? I don't know how to find this guy's username in all this stuff. I don't even know what SAMR protocol is. So how can I find it? Well, let's just do a plain text search. Find packet. Oops, turned it off. Find packet. I want to make sure there's no filters here because I just want to search everything. Packet details instead of packet list or packet bytes. I want to search as much as possible because it's a plain text search. I want to search with this wide UTF-16. I want to search on a string instead of a hex value because I don't want to convert his name into hex and make it confusing. So there's different options there. We'll leave it case insensitive, so we'll leave it unchecked. Search for his name and see what comes up. So I've made note Plucero is the username, Pierce Lucero is the infected person's name. See where we are in the list. We've got our host name already, if you remember the desktop from earlier. We've got our person's IP address. We found their MAC address. Plucero, and it's, what was it, Pierce Lucero. So we could fill in all the details. Indicators of compromise. We've got those IP addresses, the 72.5.43.29, I think it was. There was a 172 one in there, and there was a couple other ones of concern. What else have we got? The domains, definitely the checked FedEx. So you could break that down. You could do the business.checkfedx. That's where the malware, I think, downloaded from. Or was that just the IP? The business.fedx was in the invoice to do the reach out to download the malware, but the malware came from the 72 address. So you got the URLs of that check FedEx. We've got our different IP addresses that came back suspect. What else have we got here? We could do the SHA-26 hashes. If you upload the files directly to VirusTotal, it will give you the hashes. And I've already cleared that off, I guess, so it won't show it now. But it will give you the hashes if you were to upload the file. Alternatively, you can create the hashes on your Windows machine and just upload the hash to VirusTotal. Let me see if I've still got that in history. I don't have it in the history here. But there is a way to generate the hash from Windows. I'm not sure if we did that a few weeks ago or not, but it is in there. What else have we got? I think that's about it. It would just be a matter of then of filling in the details. You've got some timelines. You've got some all the different details you could start to put together. So I think I better wrap it up there. So we've lost almost. Well, I guess we still got a few people here. I think I'll wrap it up there. That kind of answers all the questions in a roundabout way. We can sort of piece together all the details. So is anybody completely lost? Have I made it worse or easier, or just different?
No, this was good.
Ernie, this is
It was amazing, really.
this is
I got to learn a lot.
This is great.
Okay, good,
Great.
good.
I just wanted to ask too. Was this recorded by any chance on your end?
Yeah, I've got a recording running, so I'm going to try and post that up later.
Good, man. Thank you.
And you didn't infect your computer.
No. The files are there. Like you saw, Defender did grab the one fairly quick, so that's kind of nice to see. But on the other hand, some stuff makes it through. Like you see that first invoice file. That's not an invoice. It's that malicious piece of JavaScript. That made it through no problem at all. So we're lucky that Defender gets it next. So if we ran it, I think I've got Defender turned off right now, so I'm not going to bother. But in an isolated way, you could run it again and just see what happens. You could watch Wireshark at that point and see how it's communicating.
So in the code, just really quickly, in that JavaScript code, did they put all of that garbage in there just to make it harder for, like Rebel was saying, like a blue team to kind of figure out what all that was, and just to kind of, and also, like you said, to get by Microsoft, just ignoring all that. But
it's still something, right? Like
Yeah.
to kind of make it harder.
Yeah, like, here's a comment: aging demographics, memory study, I'm not going to try and say that at this point. MPI character, Fortran. It's just comments. So we can. This is a very, very, very simple reverse engineering. Is in this JavaScript is just take out these comments and see what's going on.
So
and
this is why some of those antiviruses weren't able to pick it up
correct. Yep.
because they.
And the fact that it is, in a sense, it's just simple JavaScript. It by itself is not malware. What's going on is when you start to see something like this GET request to this address, and even still, that's not necessarily malware. I can put a GET request to one of my websites, and it pulls back perfectly legitimate data. Like it could pull back from a weather API and say the temperature in Windsor is 22.1. I got a machine running here that is a digital display dashboard. So it makes a GET request to my weather API to give me legitimate weather. But again, if I take this URL and say, okay, well, that doesn't look right, and I stick that into VirusTotal, it comes back with all the red flags.
So it's definitely not them writing malware in JavaScript. That's where I was
Correct.
confused because I know
Correct.
JavaScript. I'm like, I didn't think you could do that. Okay, they're just inserting something that's going to take you
Yes.
someplace else that's going to actually
Yeah.
do the okay.
Yeah. So
That's-
if we put this whole URL in into a browser, let's see if it actually does download it. It looks like
Are
it
you
looks.
sure you want to do that?
It looks like it's going to time out here.
Okay.
So they've been caught. They've been shut down.
Just a quick thing then. When we were back inside that JavaScript when you're looking through Sublime, could you remind me again why you were deleting some text? Was that just to isolate or just make it clear for us to see the issues?
Yeah. Yeah. So it was just further obfuscated. Let me just jump back to this line because this was a really nice line. It gives us our malware source where it's coming from, but it was obfuscated. I would just start undoing some of this.
So, like, if you get all the comments out, then you can actually take the script in its full form and go plug it into ChatGPT or VirusTotal or even Google maybe, and just to see what comes back, right?
Yeah, yeah. Or just to analyze it. You just want to learn what it's doing all without having to go through Google or whatnot. So, just with Phil there with what you were saying. So I'm just breaking it down, thinking back to math class in my high school days of
Right.
however many
And
years
when you
ago.
started subtracting, I didn't even notice that was a get file, get request.
Yeah,
Like, until you actually deleted the first and the two apostrophes, I was like,
Yeah.
what is that?
yeah. So it's just that exercise in simplifying. Well, two quotes by themselves when we're putting a string together, that means nothing. Delete it. Now we've got 2 plus signs. We've got our different types of quotes, so let's just make them one quote. Oh, there's our get. Here's this further obfuscated. Again, we're just working with strings, so delete this.
Python, right? Yeah.
Same idea in Python, yeah.
But because you had it in Sublime, you could see the code. It makes it color coded, so it stands out more. You can see it.
Yeah, you can see bits and pieces. It may not put it together 100%, because if I go to the start of this file, it doesn't start as a comment. It just starts data underscore where also integrated. So that, it doesn't really make sense, but it's just a matter of, it's doing exactly what I did really, is just a quick scroll. And now it's going to give me a hard time here. Hopefully I didn't crash it. But it's just, okay, what's going on here? And I'm so used to this from many, many years ago, dealing with breaking copy protection on games and stuff, is just scrolling through. What I'd be used to scrolling through is what we see in Wireshark is this hex stuff on the right-hand side, the bottom right-hand side. I'd scroll endlessly through this to try and find identifiers, whether that's in the ASCII or whether that's file signatures that we kind of talked about today. So that was kind of good timing. Just to find those and say, okay, well, this is a file signature for this certain copy protection. I can actually go into the hex code and delete those out of there and break the copy protection sort of thing. Same idea with this JavaScript, this file here. It's what's this sort of stand out here in colors? Oh, look at this. Here's a cat. You might be aware of this, or anybody else that does JavaScript. Try catch, and then we got our function name. Sure, it doesn't look like anything, but it does look like legitimate code. So if we stripped all the comments out, we might want to do a search and replace on this, and start making some different, we might just say, okay, this is variable A, this is variable B, until we start to understand more about what it's doing, and then we might make more sense of it. It might not even be used anywhere. Where's my find? One match. So technically that's not even used. So we could say that's not, unused, just give it some English to it just to make it make sense. And then if we got everything separated out enough and we start to see the actual program itself, then further simplify it as well. This variable is unused, let's just get rid of it. This variable is part of a website address, so we rename it and make it more obvious at that point. So does that sort of fill that in and explain that a little bit?
Yeah, for sure.
Okay.
Definitely.
Okay.
I definitely missed that part. So
Okay.
most, well, just thinking on top of my head, I'm sure there would be some sort of Python script to be able just to remove the comments, and then you can just output whatever's remaining there instead of having to go sift through it. But if they obfuscated it to the point where it's like that, then that script would actually not really be ideal in that case.
Yeah, it could break it. Like I said, I sent this file to ChatGPT thinking it would be easy work for it just to separate out all the comments, but it broke it significantly. So yeah, just play around, do it manually, make some Python for it if you wanted to try it. That might be a good project that I do later. There's
the file that you're using to read this right now?
It's called Sublime.
Sublime. And this is like a Mac thing, right?
No, it's available on all the operating systems there. What's going on here? Sublime. SublimeText.com. And you can download for Windows, you can download for Mac, you can download it for Linux.
So is this like the same thing as Python visuals? What was that?
VS Code.
Yeah.
Very.
It's
Go ahead, Kat.
Okay.
no, that's okay. It's similar. I think Sublime. And correct me if I'm wrong. It's more I think more programmers. VS or the Visual Code. A lot of web designers use it. I think the Visual Code is better, but Sublime is better for some other things, I think. And I know both my brother-in-law and my brother are both into programming and networking, and they're like, if you want to start off, Sublime is good to learn and use. Every company's going to have their own editor that they want you to use, or that maybe that they prefer, but I know a lot of programmers who use Sublime, they really like it.
Yeah. It's very lightweight as compared to VS Code as well. So
to ask, I could have everything that you're doing here. I could pretty much do in VS Code.
Yes.
Correct.
Yes.
And then can I apply an API like you did from the ChatGPT to VS Code?
I'm not understanding that question. Like you're talking that program that I've got here, this here?
No, but like is that it? No, like regarding ChatGPT. You know how you said you could kind of like use it as an API?
Oh,
Or you can get an API key?
yeah, you can do that in ChatGPT as well. Yeah. I do that for different programs. But what I mentioned earlier was with this Python code, it does need an API key from VirusTotal. So if we were to go to VirusTotal,
I'm sorry, what is this API key exactly?
so it is just a string of characters, and I don't mind sharing it here. It's a string of characters. It's a code that identifies me as the legitimate user of VirusTotal. Because it's a free service, like I say, I mean, if you wanted to write that down and steal it, go ahead, but I can just hit delete on it in VirusTotal, and then it no longer recognizes it as valid. But it's just giving my Python code here authorization to use VirusTotal
Sorry,
programmatic. So the key, it's just a unique identifier to me and this program. And it lets my Python code talk to VirusTotal programmatically. So I don't have to go through one at a time and dump all those URLs, those IP addresses in here.
Okay, so my understanding is, is there an API key for ChatGPTs?
Yes.
That we could start
Yep.
assimilate. So we could use ChatGPT's API, assimilate it with VS Code, and then get it to like somehow working for us there in that environment. Is that correct?
Yes, there's other ways you can use AI in VS Code. I use one called Cody.
Okay.
GitHub Copilot's another one. So yeah, there's different ways you can do it.
And then we could kind of like teach it how to remove all those things like you did instead of taking it straight to ChatGPT.
Yeah, yeah.
It probably have a better function. Okay, that's what I was trying to get to. Okay, that's
Usually don't certain programs allow you to download, like they're almost like, what do you call it? Like extensions, like in Google Chrome, they let you do that, right?
Yeah.
So you just have to check to see which ones are compatible and which ones can do that. You can Google it probably. Does that make sense, Rebel?
Yeah. Just because I was seeing about these APIs earlier in the week regarding ChatGPT, and I didn't understand how to use them.
Mm-hmm.
And I was kind of noticing somewhere in VS Code, might be able to do that. And I was trying to figure out how I could inject that, and does that correlate to the site directly? I wasn't sure until Ernie started showing us.
Yeah, they're just add-ons. I'm sure there's a YouTube video somewhere for VS Code. They are really good about the company itself. Yeah, they do a bunch of different things. Like they even teach you how to build a GitHub with using VS Code, or like so that you can take it into GitHub and do things like that, so you can do your portfolio. I wasn't sure if it was you or Mahad that was working on your portfolio, but anyways, hopefully that helps you.
Yeah, it did. Thank you so much.
I have to go though.
Okay, yeah, no problem. Yep.
And thanks for taking all this time, and thanks guys for coming, I guess, too, to just, if you play around with that website, just be careful.
Yes. Be very careful with what you're extracting and what you're doing.
And good luck, and let us know if anybody does it. Let me know what you're doing. Like, I just want to know what it's like too.
Mm-hmm.
We'll document it. Thank you so much for this too, Kat. Yeah, okay.
Yeah, so just actually, I'm not sharing the right screen here. Share entire screen. Okay, let me just drag it just to sort of, hopefully it clarifies a little bit more about API keys. So this is just a website that I built. It's just sort of in a demo stage with what you see. But I kind of mentioned it one other day with policies. I think it was in one of the lectures, or maybe it was in an office hours. We were kind of talking about different policies, password policies and this policy and that policy. They're not really any good unless they're enforced. So I've got these policies that I've written for one of my clients, and then they're like, well, how do we enforce them? So I have this website that I call company quiz, and it lets them plug in all their users into the system and quiz them on the policies that are given. So I've got an option in their official version that lets them train ChatGPT on all the policies. So I have the policies. I just tell it, click a button here, learn this one, learn that one, and so on. And then we can basically build a quiz. So this one here is just kind of public-facing little demo thing that I threw together when I was first doing it. So I can go to an AI quiz, and this is using ChatGPT's API key in the background. So I can just do what's something we let's build a quiz based on Wireshark. We'll go 10 questions, a number of options. We'll hit generate quiz. So it's using my API key for ChatGPT, and ChatGPT is going to give us 10 questions with 4 options each, all about Wireshark. So it'll take a few seconds. Okay, what is Wireshark? Is it a network protocol analyzer, web browser, and so on? The green ones are the correct answers, so we could generate the quiz out of that. Oops, I already did that. Sorry, I haven't used this for a while to know where I even go in it. But it's using that key in the background to communicate with ChatGPT without actually us as a user using ChatGPT in the front end. So copy this quiz to the company, and then we could go from there and we could deploy it out to the different users. So all of this that you see here, ChatGPT just made in the background because I gave it that key that says I'm an authorized user to use ChatGPT programmatically. Does that sort of help answer that?
Yes.
Okay. And then, yeah, so the same thing you could do with, in VS Code, there'd be different extensions that you can plug in your ChatGPT key and have it work however you want. Earlier on in the program, I gave a, where is it here? There was a command that we can do in the terminal that we can install in the terminal, and it ties to your ChatGPT key that lets us go LLM. Tell me about Wireshark. And again, that command LLM ties into my ChatGPT key and lets me use ChatGPT without actually using ChatGPT like the website.
Wow, that's pretty awesome.
Yeah.
Like, so how many hits does that take? Because I'm sure you, like, I mean, if you run it quite often, you're going to hit that free tier limit.
Oh yeah. I've run it at the free tier. Actually, I don't even think you can do the API free anymore. But because I use it for commercial purposes, I've got I pay for
Right.
it, and with what I charge the company for using this on a monthly basis, it more than
Makes
pays
sense.
for itself. So
Yeah.
Do you have the corporate version or?
I don't have it set up and running like on a public website here at the moment. No.
Your ChatGPT's on your own machines?
Oh no. It still reaches out. Like this program here that you see running this website. When I hit generate an AI quiz, it reaches out in the background to the official ChatGPT API
No.
service.
I mean, with your ChatGPT, what version is it? Is it like an enterprise version or just the first paid version?
Oh, it's it's ChatGPT 4.0.
Like the $20 a month one. Okay.
Yeah, whatever it is there, 4.0. And then I get the images. If you look at my reports and stuff, it's all based on so I get to use DALL-E image generator in there. So if anybody looks at my my reports, you'll see sort of I forget when I started doing it, but fairly consistent design
Right,
out of just a simple prompt like this. Sometimes
So where
I'll
would I find my API key?
This is the 7th, right?
So yeah, so I'm paying for it here. Actually, no, because yeah, you've got to go into a different section for the key. I don't remember now. I just pay the bill every month.
It's probably in your settings, in your logo in the top right and stuff.
Actually API login down at the bottom here. So if I log in here,
Just like a different section. Okay. Integrate open AI model into your application and business.
so there's my API keys under this one. I won't go in there because I don't want to have to reset my keys from.
Got you. So when you go in there, there's going to be a set of codes, or is it like a string that you just take and put into your Python, whatever, and it'll incorporate it?
Yep.
Wow. Thank you. All right.
That's pretty much one step closer to automation, right?
Yeah.
Thank you so much, Ernie.
So-
That was brilliant.
Yeah. Anybody else with questions on this? Like I say, I hope I haven't confused anybody. My main things, I wanted to sort of show some starting points. So I think I've done that. Endpoints I like to see because I can build that network topology. Files are kind of nice to see. If we go to File, Export Objects, HTTP, especially when we're dealing with malware. It's like, okay, what's gone on and when? So those are just a couple of really good starting points. And they gave us some, and that's without looking at all this stuff that they already gave us in the report. So they've already given us IP addresses of concern. They've identified things as hostile or potentially hostile. So they've already given us some good starting points there. But I wanted to try and go through a bunch of it without diving too much into those, and hopefully that sheds some light on anybody who's having some struggles with Wireshark.
Brilliantly. Like, you should have your own course. I don't know what Lighthouse is doing by not hiring you and giving you a paycheck, but it's crazy how much we learned so much more from you. Like, it's weird too. Like, did you notice how Monday and Tuesday we didn't learn anything about what the teacher taught us today? Like, I felt yesterday we should have had a little insight on day 2's worth of stuff, because that was a little intricate. It would have been nice to have had that little preset before he started really going into it.
Yeah, exactly. So.
And this, like, if they taught us like this, would have been great.
Sorry, I missed that.
Yeah, YouTube channel, you got all subscriber here.
All right.
So your goal was to actually teach us and what to look for in particular as a starting point. It's really good.
All right, good.
And like everyone else is saying, it's way better than the Lighthouse course at this point because it's more hands-on. So thanks again for the time.
Yeah, no, that's good.
Honestly, it's really great.
Good. And like I say, I'm certainly no expert. I'm just fumbling around with it just like you guys are. So I'm just sort of taking bits of things that I already know and can recognize and saying, okay, how do I fit those into this puzzle that I've been given? So I know my HTTP and my web and gets and puts and posts and stuff, so I can sort of filter that. I know about extracting some files and digging into those that way. So that's how I put the puzzle together. So.
Thank you for teaching, though. Thank you for teaching what you know. Thank you. It's been very, very helpful.
Yeah, no, that's good. Appreciate it. Anybody else before we call it a day, or?
This was super helpful. Thanks for walking us through it. And it was also nice to see, even if you hit a block, how you kind of come out of that. Because I'm sure we're all going to experience that.
Yeah, well, and that'll be the forensics project. A lot of the stuff they've been showing us to date, even though it's a little bit of helter skelter. Right now, you'll start to see it come together in the forensics project. Oh yeah, I remember that from like 2 or 3 weeks ago and whatnot. Don't get me wrong, you probably still hit some stumbling blocks, but I didn't get like all of this week's or even last week's or a couple weeks. I forget what week it was that I did the forensics. But it's like, okay, I've hit a roadblock here and I've got to leave it. It's like that puzzle again. I've got half a dozen pieces in the corner. I've got those figured out, but I can't spot the remaining pieces. So let me start on the next corner or the center. Here's a couple of pieces that I don't know, but they group together. They work. They start to build that image somewhere else. And then it's just start piecing them all together until you've got the whole picture in place. So that's kind of how I explain it. So.
Yeah, good to know then. It's not to not lose hope if you only have a part of it, to just keep searching.
Yeah. Definitely don't think you've got to go linear. I can't speak anymore today. Yes. Question number one, you don't have to start there. If you don't understand, I'm not sure where it was, but we're kind of going off on the off track. And that's not it. Okay, so this such one. That was comments. Let me see here. Questions. What's the operating system? Well, you should be able to get into some of that fairly easily. But you might not. Maybe you want to go, okay, well, what is the time of the server? That might make it easier for you to start there. Just don't get, this is actually a trick question. But that might be an easier starting point. Was there a breach? Well, I don't know. Leave that, put it aside, jump around and fill in the blanks, So knowing that I said the time of the server might be a trick question, well, at least make a note of the time. And then, okay, well, I remember, why is that even a question on there? What's going on? And come back to it later. You might think you've got the answer, but just review it later and go through. Let me see here. What malware was used? Just fill in what you can, bounce around, go from there. And on the subject of this, I'm certainly glad to help anybody at any time with it. If we get a group together, that's bonus. If not, one-on-one's fine too. So. And there's lots of different ways of answering each of these questions. So.
Amazing, well, thanks.
You're definitely going to hear from us.
Yeah.
I enjoyed this project. Like I said, it put a lot of stuff into perspective. And even just as the weeks caught up to this project, it's like, oh, okay. I felt like typing in the comments on some of the lectures. Remember this for week 10 project or week 9 project, however we look at it. But I kind of had to bite my tongue on that, and I'll let you guys figure it out or see it for yourselves. So, but at least hopefully today I give you a little bit more to go on with Wireshark for anybody, like I said, who is struggling with some starting points in it and just the vast amount of data. Because if you got 20,000 lines of something in there, it's like, okay, yeah, where do I start in all this? Does the red stuff mean something? Well, it does, but it doesn't. There's some times we can look at that and, okay, yes, here's our starting point. But for me, it's, like I say, it's breakdown. Okay, what's the network going on? I put my skills to work with programming and let it do an analysis of all those IP addresses. Maybe you want to do it by hand. Maybe you don't even want to start there because we've been given an information of a malicious IP, that's 72. But as you saw, there was also some other malicious IPs that were associated with what was going on. So it's putting together the puzzle. That's all it is finding those trouble spots and piecing it together.
That was actually brilliant the way you did that too. That was very impressive.
But again, it's kind of my way, take bits and information out of my way of doing it and make it your own, So say, well, I'd rather go and do it this way, or I like that idea, but I'm going to use that idea combined with my own idea. It's however. I don't think we can definitely say there's a right and wrong way. I might be wrong, but I definitely don't think there's a step, 1 through 10 to follow. Aside from step 1 being make sure your machine's isolated, because you don't want to get infected. So.
And the way you even incorporated this program of yours, you see how they taught us how to create system log files, right?
Yeah.
And we could store the system log files into text in a folder, and then use a simple command or a program like this to isolate the information and do whatever we want with it. This is brilliant.
Yeah.
So this will actually help us a lot in the future. So
Yeah.
It's a great way to see an example of it in play.
Yeah. Yeah. And yeah, by all means, like, take a look at, where is it here? This guy's website, malwaretrafficanalysis.net. I'll post up some links and hopefully the video, if it works out. Hopefully there's no missing frames on it, to have broken up text, or broken up words, but I'll post a bunch of links and stuff, but take a look at it, but be very, very careful. So keep that defender turned on if you're using it in Windows. So.
And make sure no bridging connections.
Correct. Even NAT networks, like I was saying at the start, I'm on, I shouldn't say that, I'm pretty sure I'm on a NAT network here. Yeah, I'm on NAT network here, but it's troubling when I go ping 192.168.2.175. That's my main server with where I am at right now. So this VM can reach that server. But like I'm saying, there's, fingers crossed, there's no vulnerabilities on it. I know exactly what's open, and I know there's one system that's open on it, but it's not really open. It's protected, firewalled, and authenticated
So you did
user
that on
access.
purpose?
Yeah.
Okay.
So.
Can I ask why? What was the reason to give access to that? What was the benefit of giving that VM access?
It's just it's just to show you guys that you might think you're isolated, but you're not.
That's how I always felt about those. So what you did was you just put it, you set up correctly the firewalls and everything around it.
Yeah, like my own networks here, my Calgary one's got its own firewall running. The one here where I'm sitting in Ontario's got its own firewall running on the internal side. So things can't communicate that aren't supposed to communicate.
Gotcha. That's cool.
But I, like I said, I wanted to leave this open to show you guys that it's there. Just because it can see it doesn't mean it's open and able to be attacked. But on the other hand, it's also like, okay, do I really want it to be able to see that network of mine? So
I guess in this case, what will happen then? Two questions. One of them was in the beginning. I remember you were mentioning a guest network. So if it's on a guest network, would that change because you're on different Wi-Fi access instead of having the same internet access as what this machine is?
So, and that would kind of come down to then at that point the router. As long as the router is kept separate, it would have to reach out and then come back in to be able to see it. But as long as those two networks are kept separate, they shouldn't be able to see each other. I don't even know what my guest network. I don't have anything on it right now to be able to ping it.
Okay.
But
and I guess.
Go ahead.
But yeah, and the second thing is really just if you had your VLAN set up, then something like this for the worry of cross contamination or just where getting malicious malware would have been fine.
Correct.
In that case.
Yeah. Because like we could set up a full network in our VMware here, stick its own router in there on its own network, and have that separate, or not its own router, but it's a separate firewall even inside that VLAN. So this virtual machine is here. We got a virtual firewall protecting and blocking any access going back to, my home network, for instance. We could block anything on the 2.0 subnet. So.
Yeah.
So let's say you're playing around with a virus or something on a virtual machine, right? Or it's isolated. You could pretty much just literally shut down that virtual machine and then load up a snap from earlier, and everything's hunky dory.
Yeah.
You don't need antivirus, but you still have to do background checks, I guess, because it could have been strong enough to actually leach out, right? Because some of them have that capability.
It's. I'm not 100% sure. Yeah, I guess it would depend on vulnerabilities in VMware itself. But then the big thing though would be how your networking is, because if you don't have that set up right, then you're definitely leaving the door wide open, more or less.
Have what set up?
The networking in VMware or VirtualBox.
Okay.
That would be your biggest concern, as opposed to just a vulnerability in VMware or VS Code. So that's in my opinion. I mean, I'm sure there's there'd be some expert people out there that might say totally different. When I first looked at this WarmCookie thing, I did it on a machine that was totally isolated and on my guest network with those firewalls in place. I'm only doing it now because I've looked and played and I was comfortable with doing it on a live system here.
This has been so much helpful. Thank you so much, Ernie. I appreciate this so much.
As long as I'm not making it too confusing for everybody.
I'm so happy you're in the East cohort. Holy, I wonder how the West cohort is going next. It's not even fair. So what do we? You're hosting another class tomorrow, correct? Is that going to be based on the actual project itself, or?
Yeah, I can do that. So I kind of suggested the 2:00. I was going to throw in my 2 cents at the start of this, but yeah, Kat kind of suggested, well, let's leave it until tomorrow and let everybody sort of get their feet wet with what's going on already, and unless I've taken up too much of everybody's day already and everybody's behind.
No, I'll be honest. The amount of learning we're getting here, it just makes even the reading comprehension a lot easier, because we really don't get a lot of hands-on, and you're actually saving us a lot of hours of clicking and trying to figure out things with you just explaining it, which is one thing I feel like the course is kind of missing. Except sometimes they do it for certain things, but we never had it for any of this like this. Like, this was brilliant.
Yeah.
Just tell us, you'll go through the PCAP scans and try to see what you can, but they never ever dived into it. So
yeah,
we appreciate it.
Yeah. All right. Is that good for everybody then? Everybody that's left?
Yeah. Well, thank you again for saving us future hours.
Yeah, no
Yes,
worries.
thank you.
And yeah,
Sleep more.
if you get into that project at all tonight, or just any questions on that FTK, like, let me know and save them up for tomorrow.
What about the remote?
Oh yeah.
Bird. Maybe I'll talk to you about that with you later.
Yeah, we can do that. Or if you want, I can just set it up now, and I can give you the access, and then you can take a look at it. And if you got any questions, let me know.
Yes. Oh my gosh, lifesaver.
Maybe we can even put that for the chat, the cafe chat for everyone that needs it.
Yeah, I can do that.
Perfect. Well, thanks again, and well, best of luck to everyone. We'll probably see Ernie soon.
Yeah.
I really appreciate it.
This video is going to be in a heavy folder in the PK file. Right, so appreciate it. I have like an Ernie section.
Yeah.
Thank you, Ernie. Thank you.
All right, no
Okay.
problem. All
Thank
right.
you.
Yeah, thanks everybody.
Thank you.
You're welcome.
I guess I'll just wait for the address, or
Yeah, I have to copy the VM and do some tweaks on my router, and then I'll send you a private message there with the access to it.
All right, thank you so much, man.
All right.
Thank you.
Yeah, I might be a few minutes though. I got.
No worries. Take your time. Take your. No, you gave us way too much time. Don't worry. Actually, take a couple of hours. Okay.
All right, no problem.
Okay.
All right.
Take care.
Talk
Bye.
to you later. Bye.